guys, so today is going to be a really short video because there really isn't any new content today. All we're going to do today is combine solving exponential equations with solving log equations, which is what we've done the last two classes. The only thing I want to do in the video here is go over two of kind of our harder examples that you haven't seen so far. So the first one I want to go over is number 8. So number 8, this is the log of log x. So this one can just get a little bit tricky because it may be hard to see how to get that by itself. Well, in this case, the argument of the first log is log x. So what you can do here is you can rewrite this in exponential form. This would be 10 to the second is equal to log x. At this point, it's a pretty simple equation to solve. And you end up with 10 to the 100th power is equal to x. Now, 10 to the 100th power, you can just leave it in that form. That's not something you'd be able to evaluate with a calculator. It'll probably give you an overflow error. The other one is actually kind of hard to see, but this is actually a factoring question. So one thing to notice is that the natural log of x squared is not the same thing as the natural log of x squared as an argument. Okay, those are two distinct things. That's also going to be true when you get to pre-cal and you look at sine. Okay, the sine of x squared is different than the sine of x squared. And actually the notation for that when you get to pre-cal looks like this. But those are different things. On that first expression, you are squaring the entire log. Whereas on the second one, you are cubing just the argument. And I know those extra parentheses should be there to make that a little bit more clear, but the cube there is only on the argument. Well, one thing you know based on those properties, because that cube is on the argument, you can move it to the front. So I'm going to rewrite this as 3 ln x plus 2. Well, this is actually a factoring question. To make it a little bit easier to see, I'm going to use that u substitution method. So I'm going to let u stand for ln x. Well, then this becomes u squared minus 3u plus 2, which is a really easy question to factor. So then that means that u is equal to 2 and u is equal to 1. But again, we're not solving for u, we're solving for x. So I need to go back and plug back in what I originally substituted. So ln of x is equal to 2, ln of x is equal to 1. Now I can solve these by writing them in exponential form. So I get that x is equal to e squared and x is equal to e. So I have two answers for this question. And those are really the hardest ones that you haven't already seen kind of a similar question for. The rest of these are really just kind of going to review what we did the last two classes. You can get some more practice and see them combined together. Again, if you have any questions, feel free to email me, fill out a video request, or jump in that Zoom session to get a lot of options. But really today is just a good practice day for you guys.